Hello everyone, my name is Farisha Nabihah. Today I will brief you on the introduction of Phantom Lead Control, which centers around four main pillars: environment simulation, network isolation, service deployment, and integration testing. First, for our environment simulation, we establish a protracted simulated network environment called a secure quarantine zone by deploying Linux virtual machines within VirtualBox. To ensure maximum security, we engineered a heavily isolated internal network that completely cuts off direct internal exposure for the client. While preserving secure and reliable communication among trusted internal nodes, within this network, we deployed four essential infrastructure services on our server: a DHCP server for dynamic IP allocation, and SFTP server via OpenSSH for encrypted file transfers, an Apache web server to host our internal portal, and a BaraDB backend for secure operational data storage. Lastly, we conducted systematic client-side testing to validate all network connectivity, verify active service states, and ensure total compliances with our strict structural security mandates.
Hello, Assalamualaikum. I'm Noor Zainudin. Today I'm going to present the group network setup and isolation configuration under the Phantom Lead protocol. To establish a secure quarantine parameter, we configured our network adapters directly within VirtualBox. For our Linux server node, adapter 1 is mapped to N18 to allow outward internet connectivity for polling system repositories, while adapter 2 is linked to an internal network name innet with a static IP of 192.168.1.254. For the client node, adapter 1 is tried to the exit semi-internal network, mapping both virtual machines onto the same isolated local wire. Moving on to slide 2, we perform our initial connectivity verification. On the server side, executing a ping to 8.8.8.8 returns a stable response with 0% packet loss, validating that our management link is live. On the client side, running IP demonstrates that the machine successfully lists a dynamic private IP address from our local DHCP service. We then tested the local connection by pinging our server gateway at 192.168.1.254. The successful ICMP replies confirm that local client to server routing is operating perfectly. Finally, on slide 3, we conducted the coast isolation and containment test. To ensure data security and prevent exfiltration, the client must be blocked from external networks. When you force the client node to ping 8.8.8.8, Debian operating system immediately drops the backends and returns a network is unreachable error message. This definitive outcome successfully proved that our client is 100% quarantined within the network parameter, satisfying all security constraints. That concludes our network section presentation. Thank you.
Assalamualaikum and hi everyone. My name is Asmaliza Adha binti Asri. So I will be continue with the first service, which is the DHCP service. So let's go. DHCP stands for Dynamic Host Configuration Protocol. DHCP is a network protocol that automatically assigns IP addresses and other network settings such as subnet mask, default gateway, and DNS server to devices connected to a network. For the first step, I update the package repository using the command sudo apt update. This ensures that the latest package information is available before installing the DHCP service. After the installation, I configured the HP server to serve only the internal network interface, which is EMP0SA. This ensures that the HP operates only within the internal network and does not interface with the server's internet connection. Then, I modified the HP configuration file to define the subnet 192.168.1.0/24. The IP address range from 192.168.1.5 to 192.168.1.10, and the default gateway is 192.168.1.254. This allows client to obtain valid network setting automatically. After completing the configuration, I restarted the DHCP service and verified that the service status was active and running successfully. For testing, I use the client machine to request an IP address automatically from the DHCP server. The client successfully obtained an IP address within the configured range, confirming that the DHCP service was functioning correctly. Next, I performed a ping test from the client to the server. The successful replies confirmed that communication within the internet network was working properly. Finally, I verified network isolation by attempting to access the internet from the client. The result returned network is unreachable, proving that the client remained isolated from external networks while still being able to communicate with the server. SFTP stands for Secure File Transfer Protocol. SFTP is a secure file transfer protocol that allows users to transfer, upload, and download files over a network using an encrypted SSH connection. For the first step, I updated the package repository using sudo apt update to ensure the latest package information was available. Next, I installed Open SSH server using sudo apt install open SSH server -y. Open SSH support via SSH servers and enable SFTP functionality required for secure file transfer operation. After the installation, I configured the SSH service to listen only on the internet network IP address, which is 192.168.1.254. This configuration improves security by restricting access to the internet network only. Then I enabled the SFTP system and created a dedicated user account named researcher. This user account is used for authentication and secure file transfer activities. After completing the configuration, I restarted the SS service and verified that it was listening on 192.168.1.254. This confirmed that the service was operating only on the internet network interface. For testing, I first created a sample file named test.txt on the client machine. Then, I established a secure SFTP connection using the command SFTP researcher alias 192.168.1.254. The successful connection confirmed that the SSH and SFTP service were functioning correctly. After login, I verified directory access using the pw and ls command to ensure that the registered user could access the assigned directory. Then, I test file transfer functionality using the put test.txt command to upload a file and the get test.txt command to download a file. Both operations were completed successfully, confirming that the SFTP service was functioning as expected. Finally, I extended the SFTP session securely using the exit command, which properly terminated the connection between client and server.
Moving on to my specific topic, let's look at the web server configuration shown. By definition, a web server is a specialized software system that stores, processes, and delivers digital assets like HTML files and scripts to clients over a network using a request-response model. To implement this, we first ran the command sudo apt update to ensure our package repository were completely up to date. Next, for the installation phase, we deployed the Apache web server using the command sudo apt install apache2-y, which automatically retrieved the required binaries and utility package. Finally, for the configuration stage, we edited the network settings using the nano editor as shown in the output snippet. We specifically configured it to bind to our local IP by adding the line listen 192.168.1.254 port 80. This ensures that our Apache web server securely listens only to authorized HTTP traffic on port 80 within our isolated network. That concludes the web server setup. Next, let's look at how we configure and create the web page. To set this up, we use the nano editor to modify three main files: the port configuration, the default site virtual host file, and our main HTML index file. In the virtual host file snippet on the left, we explicitly bound our server to our local IP by setting the virtual host tag to 192.168.1.254 port 80. Next, we created a simple internal portal page by editing index.html, where we added an H1 heading saying "Welcome to BITS 1213 internal portal," and paragraph confirming that this is a secure internal network. To apply all these changes, we restarted our web server using the command sudo systemctl restart apache 2. Finally, we ran sudo ss-tlnp pipe grep port 80 to verify our active sockets, and as shown in the bottom output, the aperture service is successfully in a listened state on our local IP address and port 80. This confirms our internal web page is up and securely running.
Hello, Assalamualaikum, back to me again. I'm Syaheerah binti Zainudin. Today I'm going to present the individual implementation of our database server under the Phantom Link protocol. A database server is a back-end storage engine operating on port 3306 that securely stores and handles our transaction queries. As shown here, we started by running sudo apt update and successfully deployed the MariaDB server package. Immediately after, we executed sudo mysql secure installation to enforce system hardening, which toggle unique socket authentication and drop unauthenticated guest access. Moving on to slide 2, by default, MariaDB only listens to the local loopback interface at 127.0.0.1. To meet our strict quarantine constraints, we opened the primary configuration file 50server.cnf and modified the bind address parameter to our private internet gateway IP, which is 192.168.1.254. This configuration forces the database engine daemon to strictly listen to our isolated internal network card. Moving on to slide 2, by default, MariaDB entered the root database prompt using sudo mysql-u root-p. Inside the shell, we initialize our operational workspace environment by creating the Phantom Link database. We then deployed the sensitive data table schema to keep track of critical file metadata. Finally, we provisioned a custom user called internal user and assigned it with the wildcard subnet mask 192.168.1%. This ensures only machines within our private subnet range can ever authenticate. Finally, on slide 4, we conducted our verification testing. On the server side, running ss-dlnp confirms that port 3306 is listening exclusively on 192.168.1.254. On the client side, we established a remote network handshake. As verified in the final output, the client successfully fetched our seeded data records, such as the blueprint and prototype files, with zero internet reliance. This completely validates our secure offline architecture. That's all from me. Thank you.
To wrap up our presentation, let's look at the summary and conclusion of our project as shown in the slides. In conclusion, we successfully achieved full deployment, setup and validation of our secure quarantine zone inside a completely sandboxed network infrastructure. We managed to streamline local network administration using a DHCP server to dynamically allocate IP addresses to our backend clients while facilitating safe encrypted file exchanges across separate virtual instances via the SFTP subsystem. Additionally, our project successfully hosted a dependable internal web platform to grant seamless intranet portal access for authorized network entities and enable structured client-to-server relational communication dedicated to secure database storage, queries, and retrieval. Finally, through strict integration testing, we validated all network applications interact seamlessly and operate entirely without errors. Ultimately, we have fulfilled all overall project milestones by provisioning these core baselines services under rigid network containment and total internet blocking.